Well, good morning, YouTube. It is Friday. It's Friday! November 17, 2017. This morning I'm headed over to Clayton to play with a Ecobee thermostat. The customer bought it and installed it himself, and apparently there seems to be some sort of a issue with it not controlling the heat strips as anticipated. So we're going to go take a look, see what settings might need to be adjusted or whatever. Probably not the greatest call for video, as the customer will probably be right there with me. But if he's all right with me recording a little video, maybe we'll be able to share that with you. At the moment, that's all I've got on the books right now for today. But we'll hope that since it's pretty chilly outside, 37 degrees, that we'll be able to get a couple of demand service calls, maybe. But anyway, that's what we're getting into this morning. Stay tuned.
HVAC with Stephen Rardon is sponsored by TruTech Tools. Quality tools, essential support. TruTechTools.com.
So the thermostat was pretty straightforward. The auxiliary heat was allowed to operate anytime it was under 70 degrees outdoor temperature, and then the compressor was locked out at 35. So it turned into just a reconfiguration of the limits on the thermostat. Once I got into the unit, it looked a little different. So I'll show you the first thing here. The contactor is pretty well toasted. Does seem to function based on the fact that the house is comfortable, but it's pretty black. But the one that's scary is this one. That wire connection is very well baked, and then if we look down into the bottom here, that wire nut is actually melted to the bottom of the unit, and I didn't want to pull it up for fear that it would force me to fix it before I, advise the customer of it. And then the last part that's disturbing, especially when you have wiring that's doing that, is this section right here. So the wiring for the compressor goes directly to the compressor, or the compressor contactor, and then the wiring for the heat strips actually uses the pigtail that was intended for the compressor. So we got this wire, comes off of the back of the fuse, goes down to the wire nut, and then this other black wire here goes back up to the contactor. So there is no fuse protection for the auxiliary heat whatsoever. What's scary about that is that the 125 amp breaker in the panel feeds that fuse, comes back to this bar, goes to the middle fuse, and then also feeds the low end fuse here. And so there is no fusible protection of any reality, except for a little pass-through for the heat strips, and the compressor is not fused or breaker protected until 125 amps. Just for fun, I'll show you. So we've got it labeled as gas pack instead of heat pump, 125 amp breaker feeding a 3.5 ton package unit. I hadn't operated the unit yet, thank God, because I might have hurt myself. But I checked the capacitors. They're not great and perfect, but they're okay, functional. And I'm going to hook up the I-manifold system and give the refrigerant charge a gander. standing pressure is 57 psi, R22. We're going to profile the equipment real quick. We are heat pump R22, fixed orifice, 10 to 12 SEER, I think. We'll go for standard operation. And we are in heating mode. We'll get strapped up for subcooling and superheat. These types of units are the ones that make it aggravating to use the red clamps, but as long as you're willing to work with it a little bit, it's not too bad. They're just kind of crowded in here, trying to get everything into it. And then it's going to be interesting getting the blower cover on there, since we don't want to disturb the high voltage wiring that's there. We'll move that once we get the system operating. I'm going to go drop the air probes inside. I don't know if you're going to be able to hear it, but I was kind of confused by the fact that we've got a non-original 50 amp fuse in the unit when the power's not actually going through the fuses per se. I guess it does, because it comes from here, goes through there and back through, but I just found that this fuse is open. That one's closed. That one's closed. That one's closed. That one's closed. And that one's closed. So I'm actually thinking, since this is the only incoming power for those heat strips, that they actually haven't been functioning. So I'm gonna have to grab a fuse for that, but I'm gonna cut out that wiring that has been baked and try to put things back together as they should be. Power is off, so we're good there. But I'm gonna have to, so we're gonna cut back on these burnt wires. And those go to the condenser. Nice and crispy. And then here we were melted to the bottom. Cut back there, there, and there. I think the only thing with this whip is that it's a little short once you cut your wires out. Huh. So I may have to see if I can catch up some slack on that whip, which it looks like we should be able to do, because it droops like crazy right there. don't see a clamp that has been lost. But obviously the old hood was significantly larger. I'm gonna see what has to happen to get that wire a little more direct so that I've got enough slack to play with. That's tough on the cold fingers. So we need to make up a little slack. It really shouldn't be hard if I bring that conduit down. Yes, it's pretty going up, but without running a new whip, I don't know if it's logical to worry about pretty right at the moment. I think I have some more clamps where I can pretty it up just a little. I need some slack, so we're going to have to be thankful for what we have. I knew that was going to be the situation. We've got Romex in the whip. I don't see any reason not to use the same connector yet. It's aggravating. And that might be the reason not to use this type of a connector. Like an idiot. I just wasted my time doing that. All right. So we're going to land our ground wire at that terminal block. see really the need to pigtail it over to that ground screw, but never hurts to bridge grounding when you can. Cap off the extra white wire that we have here as it was before, and then strip off the wires for the fuse block. Bring those up from the bottom, tighten them down. Kind of interesting to me that the fuse that we have dead is the one that would typically go to the contactor. But the fact that it's dead only means that part of the heat strips won't function. We got that nice and tight. Got these wires for the compressor. Not wanting to come. Got it. Alright. I need to change that contactor, and I'm actually wondering, no, it's not intended to have these wires go that route. Yep, let's get that contactor done. You're not going to be able to get a good perspective on that, I don't think, unless we go up like that or something. Coming. Power. All those yellow on the top, black on the bottom. plug goes all the way in. That one's for load management. Black on the bottom, yellow on the top. Pretty sure this new contactor has lugs instead of nuts, so I'll just cut that out. Strip it back. There we go. Alright, load management goes back on. And then everything else is plug and play. Yellow on top, black on the bottom. I think we're good, other than splicing those wires for the heat pump compressor. And on my first search through the truck, I did not find wire nuts large enough for that circuit, so I'm gonna have to look again. Here comes the moment of truth. I pulled the burnt fuse out and swapped one of the ones for electric heat for the time being, so that I can confirm operation before I go grab another fuse, so that they're not without heat in the short term that I need to go grab a fuse. I'm gonna go turn it on and see what we get. At this point I'm kicking myself because apparently I never bought any fuses for truck stock, and now I'm burning up time having to go get fuses. But it is what it is, so we'll grab some fuses and turn right onto Garner Road. Get this taken care of. The fuses should be 60 amps based on manufacturer spec, and so the 50 that's in there, I'm going to change that one and install a new 60 amp fuse for the one that burned out. I didn't think that those fuses would have any reason to get burned out, but apparently maybe just the heat generation by having voltage applied to them is enough to have killed that one fuse. Unfortunate, but it is what it is. So we'll be back in just a little bit. So there wasn't a whole lot left to get video of on that unit. The fuses went in. The heat strips checked out okay. It was pretty evident that the heat strips had not properly operated for a while. So burned off the dust on the heat strips and confirmed operation there. It's got a 15 kilowatt heat strip in it on a 3.5 ton, which is pulling about 65 amps. And 15 kilowatts on 3.5 tons in different parts of the country makes some sense or no sense at all. And for this part of the world, 15 kilowatts on 3.5 tons is typically excessive. Not to say that it isn't, you know, beneficial in a way, but when you look at the overall system power consumption, the compressor by itself pulls about 5 kW, and the auxiliary heat pulls almost 16 kW. You know, I said, since the system has not operated properly to this point, feel free to let it ride with the 15 kilowatts and see how it goes. If you want to either take out 5 kW or downgrade to a factory 5 kW strip, we can do that. But since it hasn't operated properly ever, let's just see how it goes. And the fact that he's got the Ecobee controlling auxiliary heat now, he should, he will probably actually see a rise in his power bill because the heat strips have apparently not functioned properly ever. But the fact that the Ecobee is cutting those out unless it's below 35 degree ambient should be a bit of a saver there from what it would cost otherwise. It's always nice to have opportunities to take someone's power bill and lower it, but sometimes it's necessary for proper performance to actually raise the power bill. Comfortable performance. But anyway, I posted a picture on Facebook about the job that I went to yesterday, and I'm kicking myself for having missed it, but that air handler has a 14 gauge supply wire, and the fact that it's a 14 gauge supply wire means that there's no chance of putting sheet strips in it. But my hope in the fact that I missed it initially is that when I get back, the feed wire to the disconnect will be something other than 14 gauge, and we can, you know, get enough wire gauge between the disconnect and the air handler to properly feed the ampacity of the unit with a 5 kW heat strip. I can't imagine that the unit was fed totally in 14 gauge, but honestly I missed it. I've got no one to blame but myself for not having paid closer attention to that particular detail, but that is the beauty of social media. It gives you the opportunity to, you know, share your experience and get feedback from other people. And obviously when the only thing you're looking at is a picture, there's a higher probability that you might notice things like that that wouldn't necessarily be glaringly obvious while you're there looking at the air handler, talking to the customer, and, you know, overall or overview of the system. I am headed back to the house to work on editing videos and whatnot, and we'll hit record if we come up with anything. If not, thanks for watching. Like, subscribe, comment, and share. And don't forget, you can use coupon code RARDON at TrueTechTools.com to save 7% on your purchase. We'll see you on the next one. Peace.